proportionality theorem stuff, right? For Euclidean geometry, specifically for grade 12, right? We have this question here. It says the following. It says, in the diagram, XMN is a straight line. And it is. There's X here. There is M here. There is N over there. It's a straight line. So they are trying to tell us that it's just one long line. You don't want to think that there's a bend here or whatever. They're almost just trying to tell you also that these angles are going to add up to 180 because the angles on a straight line, you know. Whether that's useful to us for now, we'll see as time goes. And then here they said it's a straight line and xt is a tangent. So obviously, if xt is a tangent, we would want to think of the tan-chord theorem. Never think that the tan-chord theorem is overrated because it's actually quite underrated. So here, this is an angle at the tangent and the chord. It is equal to the angle in the opposite segment. So on your side, if needs be, right? Remember, you can mute your mic, and then if you need to say anything, you can always then what you may call unmute it. So tan-chord theorem here, we have identified it, you see, and you can see. Try not to feel rushed to see what questions they're going to ask you. You see, because a lot of the things that I say, I know sometimes it may seem like maybe that's just my way of doing things or whatever. But then with Euclidean, you see, all that you need is your description. The other thing is the only way your description is going to be useful to you is if you know your theory, if you know your work. This example here, the description was useful to us only based on the fact that we knew the theory. We knew things like the tan-chord theorem, and we definitely knew things like the proportionality theorem, which is how we're able to see why this was given. So with the tangent being given here, obviously the tan-chord theorem is something we can definitely see. Secondly, let's see what else. They said here, y is a point on xn. So there's y here. It is a point on xn. That is correct. And then they said here, it's a point on xn so that xy is equal to xt. So don't always find yourself putting information onto your sketch as you read the description. So for example, now we know that y1 over here, the whole angle there is equal to the whole angle over here. The whole t1 plus t2. These are equal because these are angles opposite equal sides. So that's important. So with that being said, right, we can even maybe, again, when you see that there's too little information given in your sketch or given in the description, I always try to put again these things here, dr, cpt. Diameter, we don't have any diameter explicitly given. Radius, we don't have. Cyclic quadrilateral, definitely we don't have any here. Parallel lines, we don't have any. Tangents, we have one, and we already said what we could say. Now, just obviously from just the way this visually looks, it looks a lot as though that Tn is our diameter. But unless we can prove it, we cannot say Tn is our diameter. You know, because this also looks a lot like it's a 90-degree angle, but as long as we cannot prove it, we cannot use it. So in as much as this looks like a diameter, it means this also looks like it's a 90-degree angle. So all those assumptions, you can just keep them in mind because they may come in handy based on the questions, you see. So here they said for 5 whole marks, we should prove that YT is this line here, Y going to T. We should prove that it bisects M, T, N. Now, whenever they ask you to prove that a line bisects an angle, what they're trying to tell you is you should prove that the angle on one side is equal to the angle on the other side. And you should basically make use of different things that you know to be true. So this is one of those questions where our dots and our line and our colors here, it looks like that's the one thing that's going to help us. And as I'm looking at this question, right, The one thing that's also standing out is that this is a 5-mark question. And from my own opinion, reading this question, looking at it, yeah, it looks like a high-level question. It's not very straightforward. But then this is where things like your acronyms help you, you see, Dr. Cape Town, and then things like TPEX. Because with, remember, TPEX, the idea is to remember that angles on a straight line add up to 180. And then things like an exterior angle is equal to the opposite interior angle of a triangle. Now, based on the dots that we put here, I'm immediately drawn towards the P, because here we have this exterior angle here that we labeled in red. And we said this angle here is equal to the whole angle over here. Furthermore, we said the blue one here is equal to the blue one over there because of the tan cot theorem. And then what we are saying is we want to prove that these are equal to each other. Adding more to that, what we can also see is that the red one here is equal to the blue one plus the purple one. And then this red one also, technically speaking, it is equal to the blue one and the purple one, because the red one here represents the whole thing. And clearly it's equal to the blue one plus the purple. The red one here is equal to the blue one plus the purple, because those are, there's an exterior angle of a triangle here. It is equal to the sum of the opposite interior angles, you see. So without, let's say, getting too caught up in the mess of what we're trying to do, our job here is, we should try and say it's simple. We just need to find a way of showing that T2 is equal to T3. That's what we need to do. So again, without, let's say, struggling too much, always lean towards what you can already see on the sketch and go towards that information and use that information. So without struggling too much, let's tell them we know that T1 is equal to N. So let's say that T1 is equal to N. The reason there is 10 chord theorem. So we can just write 10 chord. Because all we're trying to do is, you see the colors that we have put on our sketch, those are all on in our minds only. So when it comes to answering the exam, you have to tell them you know those things, you see. So T1 here, we've said it's equal to N. Secondly, well, let me actually just color code it, you know, the blue with the blue, the red with the red. It will help for us to say what we will be saying. So let me change this to blue. Woo! Yeah, it's a bit dark, but we're gonna have to change it to maybe something a bit lighter, like a lighter blue. Change style here. Which blue now? I think this blue will work. No. This blue will work. So with that being said, we need to also then tell them that the T1 and the T2 here, because remember, this is our goal. Our goal is to show that these, the T3 and the T2 are equal. So let's just try and get T1, T2, and T3 in our statements and reasons. Let's see. So here we're saying that T1 plus T2 is equal to Y1. So let's do that. T1 plus T2 is equal to Y1, which is these two equal to that. So you see, the reason I'm writing it out as T1 and T2 is because based on like how the sketch looks, it is more useful to us to refer to this angle as T1 plus T2, because if we were to maybe refer to it as X, T, Y, algebraically, it would not be very useful to us, because in our algebra, we want to eventually end up with T2 equal to T3. So that's why here it's easier for us to refer to this big angle here as T1 plus T2. So we're saying T1 plus T2 is equal to Y. The reason for that is angles opposite equal sides. Remember these equal sides, they gave them to us, you see. So here, angles opposite equal sides. So we've written our statements here. Something, there's T1 somewhere, there's T2 somewhere. Now we need a way of having T3 in our statements. And that's not very difficult, as we said, because we're going to need to make use of the P here, because we have this effect, right? There's an exterior angle here and two opposite interior angles. So we have, like, here, here's what we have here. You see there's N there, Y here, T there, M there. You see there's an angle over here, which is our Y1. We know that it is equal to the purple one down here, so, and this one up there. So we need to tell them that we know that information. So let's do it. Let us do it. So we're going to say here Y1. Let me actually write these two first. N plus T3, N plus T3 is also equal to Y1. The reason for writing that is exterior angle of a triangle. Oops, triangle. So the reason I've written out these three statements is because when you're going to prove that two angles are equal to each other, remember, no, we said so in our different examples, we've always said that if you're going to prove that two angles are equal, try to find something this one is equal to, and then try to find something this one is equal to. As you can see, this sketch is very minimalistic. There's not a lot of lines flying around. It's just too plain. So in a sketch like this one, where things are just too plain, the chances of you finding something that is explicitly equal to this and something that is explicitly equal to this, and then using that to say that these are equal, the chances of that happening are like slim to none. So you would not, that route may not help you. The route that will help you is eventually ending up with this using algebra. Now, for you to end up with this using algebra, you need to write out statements that will have T2 somewhere, statements that will have T3 somewhere. And then those statements, they will communicate with each other, which is what's going to happen here. Fortunately, as you can see, our last two statements here, we have shown that both this left side and this left side, they are both equal to Y1. So as long as they're both equal to Y1, we can conclude here and say, therefore, T1 plus T2 is equal to N plus T3. You see, we're saying it because we have shown that they are both equal to Y1. So remember, our goal is to end up with T2 equal to T3, which is how, this is where this is going to help us now. Because remember, our statement up here has given us a right to say that T1 is equal to N. We've already stated that. So algebraically, all we're going to do is let's put N and the T1 on one side. So here we're going to say T2 equal to T3. And then, or rather, let me put it this way. Let's take this to the other side, right? You're going to have your N minus T1 and then plus the T3. So because of the statement you wrote up here, you have the liberty of then saying this and this. They're just going to give you a 0, you see, because this and this, they're the same angle anyways, you see, because whatever N is equal to whatever T is, T1 is. So if you take them on one side, they're going to go away. Then here you can say, therefore, T2 is equal to T3, you see. You will be comfortable enough to write this statement based on these three things. 1, 2, 3, you see. You're not just saying what you'll be saying here out of thin air. You're not just crossing these out of thin air. You're doing it based on the logic you presented. You presented the fact that these are equal. So if there's a number here and there's a number here, if those numbers are equal, they're just going to end up with a 0 if you're on one side of the equation. And us ending up with an equation that allowed us to get T2 is equal to T3. It's all based on information that we put in when we were reading the description. And you saw how the colors really kind of helped. The colors are what made all the difference. Secondly, this made all the difference. Writing out these kinds of expressions or writing out these kinds of, what do they call them? Acronyms. You see, because the red dot here and the red dot there, us seeing that, okay, there's a blue and purple that's making up the red. There's blue and purple here that's going to be equal to the red. That was our gateway into eventually ending up with this equation, you see. So that's how you would answer that question.